All right, so we have number 6. This is the 6th lesson here. We're going to solve inequalities with variables on both sides. And your learning target is I can solve inequalities that have variables on both sides of the inequality. So the key concept here, in order to solve inequalities that have variables on both sides, the very first thing we need to do is to get the variable on the same side of the inequality, okay? The second thing you want to do is to solve the inequality like you normally would, okay? So if you end up getting the variables on the same side, and maybe it ends up being a one-step inequality, or it could be a two-step inequality or a multi-step inequality, you would just solve using that same method. And then finally, graph the set of solutions that will make the inequality true. Example 1 wants us to solve the inequality 4m minus 3 is less than 2m plus 6, and then graph the solution. Okay, so remember, the very first thing we want to do is get that variable on the same side of the inequality. So we're going to go ahead and subtract 2m. By doing that, that keeps the variable positive since 4 is larger than 2m. And 4m minus 2m is just 2m minus 3 is less than 6. And we see now we have a two-step inequality. All we have to do is take 2 steps to solve this, and again, we're just trying to solve for m. So we're going to work our way away from the variable. We're going to add 3, because if we add 3, that'll get rid of this negative 3 here, and we'll be left with 2m is less than 9. And then finally, 2 is being multiplied by m, so the opposite of multiplication is division. So we're going to divide by 2 on both sides, and we end up getting m is less than 9 over 2, or we could put that in decimal form, which is 4.5. Alright, and then finally we need to graph it. We've got m is less than 4.5, so let's go ahead and put our open dot at 4.5, and m is less than 4 is also less than 4.5, which means that we are going to shade to the left. Shade to the left. Alright. Example 2 asks us to solve the inequality 2k minus 3 is greater than 6 plus 3k minus 3. Okay, so this is a whole lot of solving before we actually go ahead and subtract the 3k or get the k's on the same side. First, let's go ahead and distribute this 2. And remember, distribute means we're going to do the rainbow rule. So 2 times k is 2k. And 2 times negative 3 is a negative 6. So we have minus 6. Is greater than, and we see on this side we can actually combine some like terms. 6 minus 3 is 3 plus 3k. Okay, so we've simplified that. Looked a lot messier than before. We want to get k's on the same side of the inequality now, and we could subtract 3k from both sides, but that's going to make our k negative. You can still do that and still get the right answer, but I'm going to go ahead and do it the other way. I'm going to subtract 2k from both sides, and I'm going to end up getting a negative 6 is greater than 3 plus 1k, or just k. Okay, now we need to get rid of this 3 that's next to the k, and that's a positive 3. So to get rid of a positive 3, we must subtract 3 from both sides. And negative 6 minus 3 is negative 9, which is greater than k. Negative 9 is greater than k. And now finally we need to graph this. So we're going to put an open dot at negative 9. K is less than negative 9. Negative 8 is not less than negative 9. Negative 10 is less than negative 9, so we're going to shade to the left. That's it. Okay, example 3, it says to solve the inequality 2x minus 7 is less than or equal to 5 plus 2x. And so remember, the very first thing we want to do is subtract 2x, or get the variables on the same side. So I'm going to subtract 2x from both sides. And when I do that, I end up getting 2x minus 2x is no x, so I've got negative 7 is less than or equal to, and that's 0x, so we have negative 7 is less than or equal to 5, and so what we see here is that we've dropped out all of our x's. Okay, this is a special case when solving inequalities, and what that means is because this inequality is true, negative 7 is less than or equal to 5, that means that all real numbers for this scenario will be true. It doesn't matter what x is. No matter what x could be this inequality will stay true. So if you have a real number, you plug it into for x, you're going to get an inequality that is true. Now there's no reason to graph this either because it is going to be every single number. Alright, example 4, this is the last example. We need to solve the inequality 2 times 3y minus 2 minus 4 is greater than or equal to 3 times 2y plus 7, and then graph the solutions. Okay, this is a messy situation here, so let's go ahead and clean it up a little bit. We know we can first distribute, use the rainbow rule, to kind of get rid of these parentheses here. 2 times 3y is 6y, and 2 times negative 2 is negative 4, minus 4 is greater than or equal to 3 times 2y is again 6y, and 3 times 7 is 21. Okay, so let's combine some like terms before we actually solve the variables. Negative 4 and negative 4, that makes negative 8, so we have 6y minus 8 is greater than or equal to 6y plus 21. And now we can get the variables on the same side. Let's go ahead and subtract 6y from both sides. We end up getting negative 8 is greater than or equal to 21. Again, we see a situation where we've lost all of our y variables, okay? We've lost all of the y variables, and if we look at this inequality, negative 8 is greater than or equal to 21, that is not true. This is not true, and because it's not true, that inequality not being true, that means that this is no solution. There is no solution for which any value of y could be plugged into this situation here and get a actual true inequality. No solution. Okay, that's it. Hope you enjoyed. Work hard on the classwork.